Hello students, welcome to Board Maths Made Easy. In previous videos we learned the theory part like what is prime number, what is composite number, what is a prime factorization, what is the prime factorization method, Euclid's division algorithm, what is LCM, what is HCF, and how to prove the irrationality. So after the theory part, now we will continue to the exercise 1.1 where we will take each problem and solve step by step. Okay, so this exercise is from NCERT, exercise 1.1. We will take up each question and each part of that and try to solve. The first question is express each number as a product of its prime factors. So it means a product of its prime factors. That means every number should look like a prime number and its powers and its products. So 140, if you can recall the divisibility rules, any number which is divisible by 2, 5 or 10 will have 0. If it is ending with only 2, 4, 6, 8, it will be divisible by 2. So in the previous videos we have clearly discussed about the divisibility rules. So try to go back and try to remember them. Right now 140, I can make it as always start with the smallest number possible, like 140 I can write it as 2 into 70, and 2 into 70 means still this also we can further divide 2 into 35. So for 35 any number ending with 5 or 0 can be only divisible by 5. Okay, so 2 into 5 sevens. Okay, that means this is 2 square into 5 into 7. Okay, so this is how you can factorize the 140 into its prime factors as a product of its prime factors. Similarly, in the next one is 156. Okay, so this also we can start with 2, even though we can do with other numbers like 156. If you add, you will get it as a 6 plus 6, 12. 12 is divisible by 3. So definitely that will also be factor. Also it is 12 is also divisible by 6. So we will get those factors when you start doing. Anyway, we don't jump into directly finding the solution. We will go step by step method. So 2 times 2 sevens 14, 2 eights 16. This we can write it as 2 into 39, and 39 how can I write it as 2 into 2 into 3 13s, because 3 plus 9 gives 12. So 3 into 13. Okay, so like this we can write as a factor. So what does it mean? Finally it is 2 square into 3 to the power 1 or just 3 into 13. This is the prime factor for number 156. Let's look at the next one, 3825. I am trying to solve each and every problem. If you go through this, try to practice, do yourself. Okay, initially you may not know how to solve, then this should help you to understand that. Not like okay, same thing I copy paste, then you don't learn anything. So as 3825, I will take first factor 5 because that is easiest. 5 sevens are 35, and then 32, 5 6 are 30, and then 5 5s are 25. So again I can do 5 into, this is still ending with 5. I can do one more round division with the 5. 5 into 5 ones 5, 5 5s are 25, 5 3s are 15. Okay, so now you need to see 153 is divisible by which number. If we add 1 plus 5, it's a 6. 6 plus 3, 9. If you recall the divisibility rules of 3, if the product if the sum of the digits is divisible by 3, the number is divisible by 3, that we know. So what I will do, this is divisible by 3, 3 into 3 5s 15 and 3 ones 3. So 51, how can we write? We can still, if you add these two digits, 5 plus 1 6, 6 divisible by 3. So I can further write 5 into 5 into 3 into 3 into 3 ones are 3, 3 sevens are 21. So 3 17 is 51. That is the reason I written 51 as 3 times 17. Similarly, 153 I wrote it as a 3 into 51. Now we always represent with the shortest number at the beginning, then the next bigger number, then 17. So the product of 3 square and 5 square and 17, all these are, remember, all these numbers here are prime numbers. None of them are composite numbers. You know what is composite number? Composite number is one which has a factors more than 2. Like 1 and itself, they will be always the factors. If any number is a composite number other than 1 and itself, there will be other factors. Okay. The next question is prime factors of 5005. Okay, this is as is in the NCERT book. 5005, it is ending with 5. Definitely 5 is the factor. 5 into 1001, and for 1001 we need to find the factor. How we have to find? Okay, so it is not ending with 0 2 4 6 8, so 2 is not a number, and it is not divisible by 4, it is not divisible by 5, it is not divisible by 10, it is not divisible by 6 or other numbers. Okay, so we need to check what exactly the factor for 1001. If you recall divisibility rules, when a number is ending with a digit 1, so the possibilities, it should be 1 into 1, or it should be 7 into 3 will give you last digit like 121. Similarly 9 into 9. So these are all some possible values. Okay, so here we need to ensure like which can divide this. So there is no such rule here in these cases. We know only the product will be one of the, the two numbers which can be ending with either 1 into 1 or 7 into 3 or 9 into 9 will get into this. So if we divide 1, we don't, anyway it is a base value, we don't need to divide, but we can explain, try to do with 3. If it is a 3 involved, then the digits should be like 3 will not directly divide. So whether some factor of 3 or some factor of 7. So I will try to do with some factor of 7. 7 into 1, 7. If I make it into factors, if I take this 7 into 1, and then 30 will be there, 7 4 is 28, then 21 will be there, 7 3 is 121. So these things we cannot directly do ourselves without practice. Next, this appears to me like it is a 11/13. Okay, so I can write like that, but you need to practice some numbers, then only you can easily understand by seeing them. Okay, this could be possible value. So now here everything is a prime factor, 5 7 11 13. So no further division is possible. So this is written as product of 5 7 11 13 prime factors. Is that okay? And then the next part of the question is 7 4 2 9. Okay, this is another example, 7 4 2 9. Okay, so the number should be either 1 into 9 or 3 into 3 or 7 into 7. The last digits of the two multiplication factors, they should be having such kind of number, then only it is possible. And here it is a bit lengthy one, like even you try bigger numbers, it's not that easy. Okay, so what you need to do is take the numbers, try to see what is possible. Okay, so based on my understanding, this could be like 7. If I try 7 into 7, 7 6 is 42, and this 9 again we can't. So can we try with the 3 ones, 3 twos, 3 fours, 3 sevens? Then again remainder is there. So let me try with the what number I can try? Can we try with 13? So 13 5 65, 92 is there, and 13 sevens 91. That is also not going to cancel out the number. That means it is going to give the remainder. So we can try with the 17. So how can we say 17 fours 68? Okay, 17 fours 68, 6 is there, then 17 threes 51, then 17 sevens. Okay, oh yeah, that will give us the number. So what we can write it as 17 into 437. Okay, so again 437, it will end here. This means either 1 into 7 or 3 into 9, any other number. So no other number. So I will write 17 into, if I make it as 3 into 3 ones, 3 fours, and again remainder will be there. Okay, let me try with the 13. 13 threes 39, and then 47. So 47 I cannot divide with 13 with a 0 remainder. So that is also ruled out. The next number is 19. We can try with the 9 also. 9 4s 36, and then 77, 9 8 72 remainder is there. So let me try with the 19. So with I try 19 2s 38, and 57. So 19 threes. So yes, I can write it as a 19 into 23. See here 23, it has no other factors. So the prime factors are 17 into 19 into 23 for this particular example. Okay, let's get into the second question. The second question is, find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the given two numbers. So first problem they have given is 26 and 91. If you look at 26, I can clearly say it is a 26 is equal to 2 into 13, and then 91 I could clearly say this is a 7 ones 7 13s. Okay, so highest common factor, if you recall, the highest common factor is equal to the least power of the common prime factors. So here the least power of common prime factors, the common one in these two is only 13, and its power is only 1. Anyway, so the least power in these two is 13 to the power 1, that is nothing but 13. And LCM is equal to greatest powers of the, it's a product of the greatest powers of the all prime factors. So if there is a number like 13 in both, we need to take only one, no need to take twice. So here 2 into 7 into 13, that is approximately 2 7s are 14, 14 13s. So 13 13s are 169 plus 13 is equal to 182. So now what is they are asking? Remember, while writing, you must take that HCF here. How do you write? HCF here we have to do step by step. HCF of 26, 19 is equal to, based on our calculation we found 13. Okay, as we took, we have to write this. And LCM is equal to, if you write the statement saying that HCF is of 26, 91 is equal to product of the least powers of the common prime factors. If you write this, people know that you know everything in the HCF. Similarly, LCM of 26, 91 is equal to 182 because it is product of the highest powers of the prime factors. Here I am not using the common. Okay, it could be common or not, it doesn't matter. So like this, if you write, now we have found here what they are asking us to verify, LCM into HCF. Okay, 13 into 182 is equal to product of the numbers. What is that product number? Product of the numbers is equal to 26 into 91. Is it true or false? That is what we need to check. See here, if I divide 182, okay, this is a question mark, don't think it has any 26, 91. See, 91 is half of this. That means 182, how can you write 2 into 91? Then this becomes 13 into 2 into 91. 13 into 2 is again 26. 26 into 91 is equal to 26 into 91, yes or no? So, yes. So, that is true. Therefore, LCM into HCF is equal to product of the given numbers. Product of the given numbers for here in this case 26 into 91. Similarly, we have the next problem that is about let me check the. Okay, so if you write step by step like this for any problem, okay, sorry if I'm okay, look at this solution again. We have first found the HCF of 26, 91, then LCM of 26, 91. Okay, then we have written here, first we have written just as a factors, 26 factors, 2 into 13, 91 is equal to 7 into 3. Then we written HCF of 26, 91 is equal to 13. Why? Because it's product of the least powers of the common prime factors. In the next case, LCM of 26, 91 is equal to 182. Why? Because it is product of the highest powers of the prime factors. So that is the reason this is 182. And LCM into HCF. LCM we found it as 182 and HCF we have found it as 13. 13 into 182 is equal to, okay, here I written in the reverse order HCF into LCM, but A into B is equal to B into A, as you know. So don't worry about that. So here even if you write 182 into 13 is equal to, it will be 26 into 91, the numbers for which we have found the LCM and HCF. So I think that is clear. Okay, for 510, how can I write the factorization? 510 I can write it as 2 into, definitely we know it is divisible by 10, that means 2 into 5 we can write it first thing, then it will be 51, 2 into 5 into 51, and 51 we know it, how much, 3 times 17, so 2 into 5 into 3 into 17, is that right? So if you reorder them in the order 2 into 3 into 5 into 17. Similarly, this is the prime factors of 510. For 92, how we can write? For 92, I would say it is ending with like 2, definitely 2 will divide. If I divide 2 into 46, right, 2 into 46, again 46 is divisible by 2, 2 into 23, correct? 23 is no longer divisible, so the prime factors of this is 2 square into 23. Now the common prime factor in both of this is only 2, and if you remember, the highest common factor is equal to What is the highest common factor? The definition, don't forget, the least power of the product of the least powers of the common prime factors. Here, what is the least powers of the what are the, first of all, what are the common prime factors in both of these? 2. And what is the least power? 2 square, 2, only 2, not 2 square. So in 2 and 2 square, we can find only SCF as a SCF of 510, 92 is equal to, for me, only 2. And LCM is equal to product of the, okay, highest powers of the prime factors. Highest powers. So between 2 and 2 square, 2 square, 3 is there, 5 is there, 17 is there, and 23. Okay, if you try to do calculation, 4 into 5, 20, 20 into 3, 60, 60 into 17, I think 1 or 2, 60 into 17 is 1020. 1020 is it will give you approximately, I think 1020 into 23 is equal to 23 for 60. So this is the LCM. Now if you multiply SCF into LCM, what it will give? SCF into or LCM into SCF is equal to 23,460 into 2 is equal to how much it is? 46,920. And if you multiply 510 into 92, 510 is equal to 510 into 92, correct? Because if you do the same math here, you will get same value, 46,920. Therefore LCM into SCF is equal to product of the numbers for which we have found the LCM and SCF. So the proof, this is the proof that any numbers you can take and prove that their LCM and SCF is equal to the two numbers multiplication. Remember, we are always talking only the two numbers. We are not talking the three number system. Okay, good. Okay, next question is to find the LCM into HCF of 336 and 54 is equal to 336 into 54. So first to find the LCM, and before to find the LCM and HCF you need to do factorization, prime factorization. 336 is equal to 2 into 168. So this also, if you keep doing, I can see something here big fast. See, 8 2 into 8 into 21 I can write, right? Why? Because I can see 8 2s are 16, 8 1s are 8. So 2 into 8 is equal to 2 cube, and 21 is equal to 3 into 7. So to me this number is 2 to the power 4 into 3 into 7. This is the prime factorization for 336. Okay, so I have done the prime factorization for 336. Similarly for 54, 54 is equal to, I can see clearly, even the 2 into 27, I want to go much faster. So what I can say here, 6 9s 54. So 6 into 9. This is 2 into 3, and 9 is 3 into 3 again. So 2 into 3 cube. Now highest common factor of 336 comma 54 is equal to, okay, highest common factor means you have to take the least common factors. Okay, least common prime factors. So here least power of the product of the least powers of the common, here 2 power 4 is there, here 2 is there. So I will take only the least power of the common prime factor, and here I have 3 and 3 cube. So into 3 into 3 cube, in this I will take only the least power of the common prime factor, 2 into 3. So the SCF is 6. Similarly, LCM of 336 comma 54 is, here we need to take the highest power of the prime factors. Okay, if the one number is present, one prime factor is present only once, then take only that one. It is not a common thing. So 2 power 4 I will take, and 3 is common in both, but the highest power is 3 cube, and there is 7 only here. I will take it as is. So what does it mean? It will give you 2 power 4 is 16 into 27 into 7. So when I do the rough work, okay, I am directly given the value as 3024. So LCM into SCF is equal to 6 into, LCM into SCF is equal to 6 into 3024. Okay, so this will give you approximately 6 4s are 24, 6 2s are 12 and 14, then 6 3s are 18,144 is the product. Similarly, if you multiply both 336 into 54, see, it will be always matching. The reason is simple. Here 3024 is nothing but, if you take 9 out of this becomes a 54, right? 6 into 9 into what will be this one then? 9 3 is 27, 27 means 3 gone, and again 32. So 9 3 is 27, 54 is there, 336. So LCM and HCF product is always equivalent to the product of these numbers. So if you remember this thumb rule thoroughly, okay, there is no need to worry. The questions will not be like this. Usually they will give you LCM and HCF of two numbers is like this. LCM is equal to this much, HCF is equal to this much, and let us assume the same case. They have given you HCF is equal to 6. HCF is equal to given as a 6. Okay, and then they said LCM is equal to 3024. If one number is 336, okay, if one of the two numbers is 336, then what is the other number? What you need to do? Simply the rule SCF into LCM is equal to product of the numbers. So here 6 into 3024 is equal to product of the numbers. We know it. One of the numbers is 336. What is the other value? Say, let us say that as B. So what you can do? Simply this you need to factorize such a way this product as 336 into something. So here if you don't know, don't worry. Here at least you can write 6 into 6 5 30, and then 6 5 6 6s, 6 into 56, 6 into 56, so into B, correct? So 6 6 you can cancel, and then 3024 divided by B is equal to 3024 divided by 56. Okay, so then you will get like you can do 7 into 8 divided by 7 into 8. So can we divide this one with 7 and 8? You will definitely get final value as 54. Okay, so this maths always match. Okay, sorry if I have not covered in the video this part, division part, but you can do this. Okay, this is pretty much easier. And with this I'm stopping for today. We have covered the two problems, each having sub problems, and we will cover in the next video the third, fourth, and fifth, sixth. Okay, so because otherwise the video gets lengthy. Thank you all. We'll catch up in tomorrow's video. Good day.